Welcome to today's Explainer. We are diving deep into a truly mind-bending scientific what-if scenario. I mean, it might sound like pure science fiction, but the physics behind it, they are incredibly real and absolutely fascinating. Imagine for a second that our planet, which has been constantly, dependably rotating on its axis for billions of years, just suddenly stops. Just a complete, abrupt halt. We're going to unpack the exact science of this massive planetary break and see exactly what the laws of physics dictate would happen next. It's a deep dive into momentum, gravity, and planetary mechanics that will literally change how you view the solid ground beneath your feet.
So, let's ask the ultimate apocalyptic question. What if the Earth's rotation just stopped for exactly 5 seconds? It's honestly so easy to take the Earth's rotation for granted, right? Because we don't actively feel it in our everyday lives. You might be sitting perfectly still right now, but you, your house, your whole city, you're actually moving at incredible speeds as the planet turns. To really understand the sheer gravity of a sudden stop, we have to recognize that everything around us, the ground, the oceans, the very air we breathe, is locked into this massive, synchronized planetary dance. And interrupting that dance, even for just a few heartbeats, unleashes kinetic forces on a scale that's almost impossible for us to comprehend.
Okay, let's dive into this. Because normally, 5 seconds is absolutely nothing. You take a deep breath, you shoot off a quick text, take a sip of coffee, and boom, those 5 seconds are already gone. It's a tiny fraction of time that couldn't possibly change anything big, right? Well, in the realm of planetary physics, time is heavily tied to momentum and mass. Scientists and astrophysicists don't look at those same 5 seconds as a brief, harmless pause. No, they see it as a window for a catastrophic energy release. When you're dealing with a planetary mass of almost 6 septillion kilograms, yeah, that's a 6 with 24 zeros, a 5-second halt isn't just a brief pause. It's a massive, violent kinetic event that fundamentally alters the physical state of the globe.
1,600 kilometers per hour. Let that sink in. That is the exact speed our equator is spinning right this very second. To grasp what happens when a speed like that drops to zero instantly, we need a super quick refresher on Newton's first law of motion, specifically inertia. Think of it like this. If you're driving down the highway at 100 miles an hour and you suddenly slam on the brakes, your car stops, sure, but your body naturally wants to keep moving forward at that exact same 100 miles an hour. That is exactly why we wear seatbelts. Now imagine the car is the entire Earth, hurtling through its rotation at 1,600 kilometers per hour. If the solid bedrock of the Earth hits the brakes, well, there are unfortunately no seatbelts for the things resting on the surface.
And because of that immense inertia, absolutely everything, and I mean everything, that isn't fundamentally anchored deep into the planet's bedrock would just keep moving forward at its previous speed. You, me, the cars on the street, entire forests, millions of tons of loose topsoil, it would all suddenly launch horizontally like a supersonic bullet. Because here's the truly fascinating part about planetary physics. While the solid, rocky crust of the Earth might stop spinning, the atmosphere certainly doesn't. The immense ocean of air surrounding us, the physical oceans themselves, and all the surface debris, they still have that 1,600 km/h momentum. It creates a global, forward-moving shockwave. The ground stops, but the world resting on top of it, it just keeps going.
So because the Earth's atmosphere is still moving at these staggering supersonic speeds, it instantly creates lateral winds stronger than the shockwave of any nuclear blast ever recorded. We aren't just talking about severe hurricanes here. These are global windstorms that would literally scour the landscape, completely stripping away the planet's surface and flattening nearly every structure standing. Even the world's strongest buildings, the ones brilliantly engineered to withstand severe earthquakes, they simply cannot handle a sudden 1,600 km/h lateral shear. They'd be violently uprooted right from their foundations. And then, there's the water. The oceans, carrying all of that massive forward momentum, would violently surge out of their basins. This generates mega tsunamis traveling dozens of miles inland, sweeping over major coastal cities in an instant before anyone even knew what hit them.
And this brilliantly illustrates the massive, mind-bending contrast between this microscopic time frame and the permanent, world-altering aftermath. The actual geography of our planet heavily relies on its spin. Right now, as we speak, the Earth's rotation creates a continuous centrifugal force. This force actually causes the Earth to bulge slightly in the middle, gathering a massive amount of ocean water right around the equator. If the spinning stops, that centrifugal force is instantly gone. The massive oceans currently gathered around the equator would immediately start flowing outward toward the poles, where the pull of gravity is actually slightly stronger. In just a matter of seconds, massive new supercontinents would suddenly emerge around the equator, while the northern and southern polar regions would just be completely submerged underwater.
Even when the Earth safely starts spinning again after those 5 seconds, the global map would be permanently redrawn.
So after 1,600 km/h winds, literal continents shifting, and mega tsunamis towering over skyscrapers, could anyone actually survive this? The sheer scale of planetary physics reveals just how incredibly fragile our existence is, riding smoothly on this spinning rock in space. Honestly, the only truly safe place to be during those 5 seconds might be exactly at the North or South Pole, where the rotational speed is close to zero anyway. Or, I don't know, maybe secured deep inside a highly reinforced subterranean bunker. Let us know in the comments if you think you'd realistically make it through those 5 seconds. It's a wildly fascinating scientific thought experiment, and it really reminds us of the massive, invisible physical forces seamlessly keeping our world together every single day.